You know, deep down, at the very heart of science, there's this puzzle, a real paradox. It's a fundamental clash between one of its most important principles and one of its most powerful tools. And honestly, it makes you question the very nature of scientific proof.
What if I told you that one of science's most powerful, most fundamental tools just couldn't be proven wrong? Think about it. From quantum physics to modern medicine, our world relies on this thing. So that raises a huge question, and we're about to dig into the answer.
All right, so let's get right into it. What's this big conflict all about? Okay, so on one hand, you've got this core rule in science, falsifiability. It's like the ultimate test. For a theory to be truly scientific, you have to be able to imagine some observation that could prove it false. But then, on the other hand, science uses probability all the time, statements about likelihoods and chances. And here's the kicker. These two ideas, they don't exactly play well together.
So let's just make sure we're on the same page. What is falsifiability, really? Well, think of it this way. If your theory can explain absolutely everything that could possibly happen, then it doesn't really explain anything, does it? A real scientific theory has to be brave. It has to stick its neck out and make a risky prediction. It has to be, breakable.
And this is where the trouble starts. The big accusation is that probability just isn't breakable. And if it's not breakable, is it even really scientific? Some critics have gone so far as to call it metaphysical, which is basically a fancy way of saying it's more like philosophy than hard science.
To really get why this is such a headache, let's do a quick thought experiment. Super simple. Our hypothesis is this coin is fair. It's got a 50-50 chance of landing on heads or tails. Simple enough, right? All right, let's start flipping.
Okay, first toss, and it's tails. No big deal. That's a 50% shot. Totally normal.
All right, let's flip it 10 times now, and, we get all tails. Now, that's a little weird, right? I mean, it's super unlikely, but I guess it's not impossible.
Okay, let's really push it. 100 tosses, and it's still all tails. At this point, your gut is probably screaming at you, right? Something is definitely up with this coin. That whole 50-50 idea has got to be wrong. But wait, here's the most important question. Based on what we just saw, have we actually logically proven the 50-50 hypothesis wrong? Is it without a doubt false?
And the answer, which is kind of mind-bending, is no, we haven't. See, 100 tails in a row is ridiculously unlikely, for sure. But it's not logically impossible. The original 50-50 hypothesis actually allows for any sequence of flips, as long as it's not infinite. So no matter what happens, we can never land that final knockout punch to prove it's wrong.
And that right there, that's the core of the philosophical problem. Because a statement about probability doesn't actually forbid any specific thing from happening. Some thinkers argued they're more like abstract ideas than real, testable scientific claims. They just don't have that empirical bite.
So is that it? Is probability just this unfalsifiable thing we have to accept? Well, not so fast. The solution to this puzzle isn't about looking at more coin flips. It's actually hidden in the way we say it, in the very grammar of the statement itself.
Yeah, we need to shift our focus completely. Forget the results for a second, and let's become language detectives. Because the secret to cracking this is buried in the deep logical structure of the claim itself.
Now, logicians have a name for this hidden structure, and I'll warn you, it's a bit of a mouthful. It's called a universalized existential statement. But trust me, once you get what this means, the whole paradox starts to make sense.
It sounds super complicated, I know. But the core idea is actually pretty straightforward. It's just a statement that's making two claims at the same time. One is a universal claim, a claim about every possible thing, and the other is an existential claim, a claim that something exists. And our little 50-50 coin hypothesis? It's secretly one of these. It's really saying, for every series of coin flips, there exists a chance that the next one could be heads.
Okay, so let's crack this code. Why does this specific type of statement create such an unfalsifiable problem? It's all about how these two parts work together. First, you've got that universal part. For every x, that applies to, well, everything. Then you have the existential part. There is a y. That just asserts that something exists. Put them together, and you've basically built an unbreakable logical fortress.
And this is the trap. The for every coin toss part makes this statement unverifiable. Why? Because you can't test an infinite number of future tosses. It's impossible.
Meanwhile, that there exists a heads part makes it unfalsifiable, because you can never, ever prove that a heads won't pop up on the next flip. See? You're logically trapped.
But the real kicker, the true source of this whole mess, is that the existence of that heads is completely unbounded. There's no deadline, no finish line. You can never get to a point where you can just stop and say, all right, that's it. It's definitely not happening.
So let's jump back to our coin. Even after 100 tails, or 1,000, or 1,000,000, the hypothesis still says, hey, a heads could pop up on the very next toss. That possibility is always out there, just over the horizon. You can chase it forever, but you'll never be able to say for sure that it's gone for good.
Okay, so if you can't strictly falsify these ideas, what's a scientist to do? Well, science is clever. It adapts. It shifts the goalposts. We move from trying to falsify to something called corroboration.
So instead of hunting for that one single gotcha moment that proves the theory wrong, which we now know is impossible, scientists start looking for something else. They ask a new question. Over time, are we seeing a pattern here? A systematic, reproducible pattern that just shouldn't exist if things were truly random. Getting 100 tails once is a fluke, but getting 100 tails every single time you do the experiment, whoa, that's not a fluke anymore. That's a pattern. That's a regularity.
And this is really the key takeaway. The real test isn't about one single result. It's about whether the whole stream of results is behaving in the random way the hypothesis predicts it should. You can think of a probability theory as basically saying you are not allowed to have any reproducible, systematic patterns. So how do we test it? We go hunting for those forbidden patterns, and that is how science moves forward.
So all of this leaves us with a pretty deep question, doesn't it? Our best, most powerful scientific theories can't actually be proven wrong in the strictest sense, only strongly supported again and again. So what does that tell us about the nature of scientific truth? Maybe it's not some final destination we arrive at. Maybe it's more like a path we're always building, constantly testing, refining, and strengthening our confidence in the ideas that best describe our world.